To continue our discussion of transformations to our quadratic parent function, we're going to be talking about horizontal and vertical parameter changes. How we're moving horizontally along the x-axis and vertically along the y-axis. To talk about these type of parameter changes, we have to use a new form of quadratic equations, which is called vertex form. All right, so looking at this example or this task, we have function g is going to be the translated version of our quadratic parent function y equals x squared. So our parent function y equals x squared is going to be moved to create g. All right, how do we do that? Well, first let's look at our quadratic parent function's vertex. Remember that we talked about this is the central point of our parabola. So every transformation that we discuss, we talk about how do we move from the vertex. So this vertex starts at the origin 0, 0. And then if we locate the vertex of our new function g, it's down here at 3, -4. Well, the first direction that we traveled to get this new vertex, which is the x direction. We moved in the x direction, and it looks like we moved to the right 3 units. Let's see what that will look like in equation form. So the first thing that we did was shift to the right by 3. And if we combine our parent function with our vertex form and compare them, this will give us y equals, well, we know our a value is 1, so I'm not going to put anything there. We now have our x coordinate, and our vertex form is a little bit counterintuitive. The equation is already subtracting, so we're going to put x minus as our starting, and we know that we went to the right 3 units, so x minus 3. I know that is completely counterintuitive from your understanding that right means add, but for vertex form, it is backwards. The equation is always given to you to help you understand that it's subtracting, and then we input the number that we're subtracting by, which will become our h value, and for us that is 3. We went to the right by 3. So that's the first thing that we notice about our vertex. The next thing that we notice about our vertex is, like I said, it's down there at -4, which means we went down the y-axis by 4 total units. So if we want to talk about this second transformation or second change that we did, we shift down by 4 units. What does that look like? Well, we continue our equation. We have y equals x minus 3 squared. And the y value is never counterintuitive. It's going to follow your notion. If you're going down, you're moving down the y-axis, we're going to subtract 4. If we were moving up, we're going to add 4. And even if you look at the equation, it's super straightforward. It's not backwards from what we understand. So there we have it, our new equation, y equals x minus 3 squared minus 4. One thing that I want to talk about is that we know that our vertex point is 3, 4, and we can always check it once we get or create our final equation. So our vertex, remember I said, is always subtracting, so the x coordinate is 3, and in the back, the y coordinate is -4. Looking at vertex form, we now are going to start using h and k to represent our vertex. It's no different than using x and y, but we've already used those letters for something else. I like to write a little x and a little y under it, but if we're going to be in vertex form, your vertex is now going to be labeled by h and k. All right, I hope this video better helps you understand how an H value can make your graph or shift your graph along the x-axis. Your graph is going to the left or to the right based upon your H value. And your K value is how your graph will transform along the y-axis. Will your graph go up or down? Will you add or subtract a number?